Next, we will have Mr. Matsuo, who is a renowned AI expert in Japan and also in the world. And we are looking forward to hearing from his great presentation. So Mr. Matsuo, the floor is yours.
Yeah, let me start my presentation for like 10 minutes. Thank you very much for this great opportunity. My name is Yutaka Matsuo. I'm professor at University of Tokyo. We are doing research on AI, deep learning, generative AI for many decades, maybe almost 30 years. And I'm serving as the chairperson of the Japan Deep Learning Association. And I'm sitting the board of SoftBank Group. And also I'm serving as the chairperson of the AI Strategy Council under the Cabinet Office. Today, I want to share what's going on in the recent academia in generative AI, and also a little bit about Japan's AI strategy. And as you know, DeepSeek has shocked the entire community at the beginning of this year. And actually, this is the demo where we make the DeepSeek to solve the math entrance exam of University of Tokyo, which is known to be maybe one of the most difficult entrance exam in the world. And DeepSeek takes like 10 minutes to solve the all 5 questions. And as a result, they almost perfectly solve the problem. So now the DeepSeek can enter the University of Tokyo. And also there are many other great technologies, and OpenAI release deep research, and I'm using a lot every day. But if you could just investigate on some topic, the deep research tries to explore the internet and make the correct the necessary information, and makes a very neatly written report in a academic paper style. And that is very useful for many purposes. And the technology behind that is the very famous ones, transformers, and also the self-supervised learning. Transformer is the collection of attention mechanism which can select the part of the neural network that is used for the given input. So it can enhance the flexibility. And self-supervised learning is also known as the next word prediction. So the model tries to predict the next word coming in. And by doing that, the model can have the knowledge about the word or causal relations, so many necessary knowledge behind the data. And that model is used for the downstream tasks even afterward the pre-training. And we have a scaling law. If we have more computers, we have more data, we have a larger model, then we get a better result. And that's why the big tech is competing each other to invest more amount of money. But the interesting thing is actually we don't really know what is going on in the large-scale neural network. And what we know is just to use the large model and large data, large computation, we get better model. But what's going on inside is not known well. But gradually we are revealing what's going on inside. The one interesting recent finding is the concept called grokking. Grokking is a phenomenon where the generalization happens. This is how it works out. When we start training, the model easily overfit. So which means the model will very the model learns or even to memorize the training data and performs very well to the training data, but it doesn't, perform well to the test data. So that is called overfit. So model overfit to training data. But if we still keep going the training, even if it is overfit, then and the training process will take more than 100 times more. Then suddenly the model generalizes. That means the test performance goes up. So that's a very interesting phenomenon. And maybe this is similar to the human case. We have to memorize many things. When we are high school or junior high, we have to remember many, theories, laws, or histories. And after several years, we have some insight to structure the field, the overview of the field, and then we can answer the more diverse questions. So maybe the same process happens in the large scale transformer models. It's not a good way to directly connect to the brain science, but I think the overall intuition is like that. And also, this is another notable things recently found is the concept called circuit. The researchers found that there is a small scale sub-network where some function is realized. For example, so retrieval, matching, or something like the very basic primitive function. And for example, if we want to make a electric circuit, we have to design that, and there is a very primitive component like a transistor or a register or something like that, and with several transistor and register condenser, maybe we can make some functions, and using that function, we can build much larger functions. So maybe similar things happens in the large scale neural network, and there is a very small primitive component called circuit, and circuit merges to the more large scale functions. So that is the how the academic research is going on in the neural network field, but yeah, we still don't know what's happening in the large scale neural network, but industry goes on and they want to try and build the very large scale neural network. I want to share recent advances in robotics because in the robot field there is something interesting is going on. This is the research in our lab, Tidy Up robot, and actually we won the competition in the RoboCat at Home Japan, surprising RoboCat at Home World competition. And what we want to do is to make an order to the robot, and the robot will behave accordingly, and the score is recorded. And what's going on is so far it was very difficult to have the robot planning and the movement of each hand or location. It is very difficult to calculate the path. But what recently happening is translation. So the large language model can translate the human language to the robotic language. So the sequence of command. So the robot can move smoothly according to the human's intention. For example, if we order the robot to pick up some apple in the table, then the sequence of robotic command will output using LLM, and which is more robust and flexible compared to the technology before. And also, what we are seeing is a very innovative change for the robotic foundation model. It's yeah, this is very famous in our community. The Silicon Valley startup named Physical Intelligence just released this model Pi Zero in last October, and the robot can do the laundry and fold towels or t-shirts, very smooth way, and it can also clean up a table or assemble a box, so they can be very flexible. And how it is realized is just like the LLM. So they use a large-scale transformer model and put sensor actuator data, and they use self-supervised learning to predict the next sensory or actuator input, and the model can recognize the environment or robot body or the task itself, and they can behave very smoothly, flexibly according to the human's instruction. And also the Google just do the same thing. The Google released the robot manipulation technology in this March, and this is the example that we say that to the robot, make a dunk shoot. Then the robot recognize what is dunk shoot and what is the basketball here, and the robot pick up the ping pong ball and put that into that. Yeah, so there is there's a significant change in the robotic field, and in order to make the very large scale robotic foundation model, we have to have the data. So there is a project called RTX is going on with a collaboration of 21 research institutes. We collect data from all over the world and make the very large data set, and the large data set is used to train the very large robotic foundation model. And what we are trying to do is to establish the robot data sharing platform from Japan. So yesterday we have a press conference to announce that we launched the IROA AI Robot Association, and this association aims to make an ecosystem or platform to collect the robotic data, in a very open way, so that the researchers all over the world can use that data to make the robotic foundation model. So it's an open source, open-minded approach, similar to Llama or DeepSeek or whatever. But we want to contribute to the entire community in the world for the robotic industry and applications. And I think that in Japan, because of the human resource shortage, maybe the robotic technologies can be used in many industries and scenes, like construction, agriculture, or retail, or medical, whatever. So I think this is a very good opportunity for Japan. So, yeah, that's about it. Thank you.